I think we're all excited about the upcoming launch of the Artemis spacecraft, first trip to the moon in quite a while, due to launch on August 29th. I've been busy doing a update to SkyTrack to hopefully be able to track Artemis for those that are lucky enough to be in a location where it'll be visible in the sky. You may be familiar with NASA's JPL website. It's a great resource for getting data for all sorts of different objects, ephemeris data. And lately they've added the Artemis spacecraft in anticipation of its launch. There is no data yet available for it. But this is a great website. If you haven't seen it before, take a look. You can download all kinds of location data on all sorts of objects. Thankfully, they have an API that software systems can use, and the next release of SkyTrack will have. So here it is. Underneath astronomical objects, there's a new tab called Jpl Major Bodies. So the major bodies would be everything in their database except for comets and asteroids. SkyTrack already has a different source for that data. So that's not included underneath this tab, just the major bodies. First thing we need to do is download the list of available objects that there is in the database, and we can just click here. I had a filter there, I'll take that off. And we can see there's 486 available major bodies that we can get data for, or at least some of them get data for. So beginning of last week, this number was 484, and since then Artemis and something else, I don't know what, was added to the database. So you don't always have to click this, but every once in a while I should click this to get an updated list. So in this list you'll have spacecraft, you'll have famous or infamous SpaceX Roadster that's out there orbiting. Although I don't think we're going to be able to pick that up anymore on our equipment. But let me just get a few things. Here's something that I took a look at last night, and I'll show you the image from that. That's an X-ray observatory that I believe NASA has, and I'm going to download the data for it. There is a start date here because it's going to download 3 days worth of data. So it's going to download, in this example, August 24th, 25th, and 26th. This is important if you're downloading ahead of time. Say you're taking a weekend trip to a remote site where you're not going to have internet access. Obviously, you need internet access to download this data. You want to make sure that you've got your range of dates you need. So if you're doing that ahead of time, you might want to change this to August 26th or something. So you got your range of dates, because the system won't allow you to use the data after the 3 days. So it has all the moons, solar system moons in it. And don't get too excited when I download this because it's not visible anymore. But I just want to show you something with it. And let's pick a planet. And I'll explain why you might want to view planets through this instead of through the normal under solar system. So there's the objects we've selected. If we downloaded something more into the future, it won't show on this date until it's valid. So it's valid from these 3 dates, 3 days. And so let's choose the observatory here. I'm just gonna pop that out. Okay, so first of all, when we choose a JPL body, you'll see here in the target object that these continually update now. So before, when you selected another deep sky object, those were static. They didn't update. And most things wouldn't update, but your solar system and comet and asteroid data might. Because we're going to use custom tracking rates, so we're not just going to go to it, but we're gonna track it, and it's going to be moving at a rate different than our normal sidereal time. In order to use these custom rates, your mount has to be compatible. And if we check under Other and ASCOM capabilities, these two ASCOM properties here, they have to say yes in order to use that custom rate. If you don't have that, what you could do is just periodically hit slew to keep the object centered. So we're gonna click that, click slew, and then the mount is gonna go to the observatory there. And there we're pretty close. Something according to ASCOM, what a driver should do is when you're using a custom rate and you do a go-to a location, it should keep updating where it's going as it slews, because that's changing because the object's moving. In this case, it didn't. It's close, but it's not right on. The software is using a closed loop to make slight adjustments if we're not completely lined up, but it bumps and does that very conservatively, and so it's going to take when we slew a long distance like we just did, it's going to take a little while for that to get lined up. So what you can do is hit slew a second time, and now you'll see we're very close. So this indicator is separation, just like we have the satellite mount separation underneath the satellite tracking. The only difference is this is in terms of arc seconds now, as opposed to arc minutes. Because we can track much more precise, because these objects are moving much more slowly than our low flying satellites do. So you can see right now we're tracking underneath an arc second, and so it's doing really well. So I tested this last night under the sky, and actually this object, and this is what I got. So there it is, and there are stars because we're not moving again at our normal tracking rate. We're using a custom tracking rate, and so there's the observatory. This is really heavily cropped, blowing up quite a bit, but you'll see these stars look a little thick too, because we're moving a little bit in declination as well as RA, but there's the proof that it did in fact work quite nicely. That's the only one I've tried so far. So when you're done observing that, you can either click stop or uncheck this, and that'll set your tracking rates back to normal tracking. So why would you want to do this in the moon? We can see the moon through the solar system, because the moon is not moving at sidereal time. It's a little different, and you'll know that if you're imaging the moon or the planets. You line them up, and after a little bit you have to give your mount a bit of a nudge again to get it centered, and because it's not moving at the normal speed. So a custom tracking rate like this will keep it lined up all night long, moon or planets. And you can see here we're extremely accurate, 0.02 arc seconds off, so it'll keep tracking it right bang on. You'll notice an option here that says use arc second per second for the RA time, and that is because the ASCOM standard actually says it should be RA second per sidereal second, And I found during my testing that not all mounts are compatible with that, and even the ASCOM simulator is incorrectly using arc second per second. So the difference between arc second per second and RA second is 15 times. So I'll show you what happens if I unclick that. Gradually, this is just going to keep increasing because it's going to fall behind. And we're going to start to see our mount RA and our object RA separate out. The moon's not moving real quick, so it takes a while, but you can see the difference already. And if I click that again, we're going to see this number go down quickly. It catches up. So I don't know which mounts might have that wrong unit and which ones don't. I know my astrophysics mount, I have this unchecked that uses the proper RA second. I have tested with the EQ mod simulator, and I needed to check it. It uses the wrong unit, so I have the feeling that if you're using a Skywatcher mount with EQ mod, that you might need to check that. I'd appreciate a couple of emails from people just to let me know what they found. And I'm not sure in the final version what I'll do with this, whether I'll just do a test for it or whether you'll have to check that. But yeah, unfortunately, ASCOM standard isn't always followed exactly. So I think that's it. So you just need again to download your list, download your data for which objects. If your mount slews a long way, then you might want to click slew a second time to speed up the centering. And again, in the final version, I might do something different about that. This is just a beta. I wanted to get it out there and get people testing. And if there's any big problems, we'll have hopefully time to correct it and get another beta version out before the 29th. And that's it. Give it a try, and we'll see what happens. And I would love to see if anyone gets some imaging of Artemis. Thanks for now.